My name is Karen Daly and I teach mathematics at DKIT, a third level college in Ireland. This video was produced to further assist my first year computing students with their mathematical studies. At the end of this tutorial, you should have an understanding of the fundamentals of matrices. Enjoy! Let's look at a typical question. You're given four matrices, A, B, C and D, and you're asked firstly to write down the order of the matrices above. Now, the order of a matrix is written rows by columns. And remember that a row goes horizontally and a column vertically. So if we write out the answer, order of A has 3 rows, 1, 2, 3, so 3 rows by number of columns is 2, 1, 2, so 2 columns. The order of B has 2 rows, 1, 2, and it has 2 columns, 1, 2, so it's a 2 by 2 or a square matrix. The order of C, it has 2 rows, so I'll go down 2, and it has 3 columns. And the order of D is the same as B, it's a 2 by 2 matrix. The main thing to look out for when doing this question is that when you're asked for the order of a matrix, that you put rows first and columns second. And also to remember that a row goes horizontally, as I showed you, and a column vertically. Now the next question, part B, asks us what is the value of C21, A22 and C31. Now C21, the first thing to note is the C is a small c, and that means that it's an entry within the matrix capital C. 21 tells us what entry it is. 2 indicates the second row, so this is the second row, and 1 indicates the first column, this is the first column. So where both of them meet is this particular entry, minus 12. If you look at the next one, A, small a, is the entry in the matrix capital A, and it's in the second row, second column. So if we go to the second row, second column, we get the entry minus 15. And for the last one, C again, we go back to matrix C, and we want to go to the third row. But as we can see, there is no third row in matrix C, so for this, the answer is that there is no entry. Just like in part A, the thing that you need to look out for is when we're naming an element, let's say the first one, C21, that the 2 here is a row. We place the row first, and the 1 is a column, the 1 is second. So row, column, just like in part A. Now let's move on to part C of the question. What we're asked is, where possible, evaluate the following. And part 1 is twice the matrix B minus 4 times the matrix D. So let me write in the two matrices. So it's twice this matrix minus 4 this matrix, which is matrix D. Now, before I begin, I must check, is it possible to do the subtraction? And for it to be possible to do the subtraction, the two matrices have to be exactly the same order. And if you look at these two matrices, B and D, they are the same order. Both of them are 2 by 2 matrices. So the subtraction is possible. The next step is to do the multiplication. So the first was 2b. So what I do is I take every element in B and I multiply it by 2. So what I get is 2 1s are 2, 2 9s are 18, 2 3s are 6, and lastly 2 times minus 4 is minus 8. Subtract, multiply everything in the matrix D by the number 4, and what I get is 4 times minus 2 is minus 8, 4 times minus 6 is minus 24, 4 times 6 is 24, and lastly 4 times 18 is 72. Now to do the subtraction, what we do is, we subtract corresponding entries. So the first subtraction will be 2 minus and minus will give me a plus, and the value is 8. So 2 plus 8 is 10. The next one is 18, and 18 minus and again minus will give me a plus. So 18 plus 24 will give me 42. The next entry is 6 down here in the second row, first column. 6 minus 24 is going to give me minus 18. And lastly, minus 8 minus 72 is going to give me minus 80. 80. So the main thing to remember in this, for this part, is that to do addition or subtraction in matrices, the two matrices have to be exactly the same order. In this case, B and D are the same order. They're both 2 by 2 matrices. And when we add or subtract, we just add and subtract the corresponding entries within each of the matrices. Likewise, when we go to multiply by a fixed number, in this case it was 2, we multiply each entry in the matrix by 2. Now for part 2, we're asked to find the determinant of D. These two straight lines on either side of D mean the determinant of D. And we're actually given the formula to work this out. This will be provided in the exam. So in the exam you'll be given that if A is this matrix, a 2 by 2 matrix, A, B, C, D are the entries, then the determinant of A is equal to AD minus BC. And A to the minus 1 is the inverse of A, is equal to 1 over the determinant times this rearrangement of the original matrix. So let me remind you, D is the 2 by 2 matrix containing these entries. So following the formula, the determinant of D is equal to. So what we do is we take A, which is minus 2, and we multiply it by 18, and we subtract minus 6 multiplied by 6. Now be careful of all the signs. Minus 2 multiplied by 18 is minus 36, and minus will give me a plus, so that'll be plus 36. So the determinant of D turns out to be 0. Now let's move on to part 3 of this question. And part 3 of this question is I'm asked to work out 4 multiplied by d to the power of minus 1. And d to the power of minus 1 is known as the inverse of D. Now the matrix D is written here at the top of the page. And if I follow the formula, what I find is that it's 4 times, right? 1 over the determinant of D, and 1 over the determinant of D is 0. And what you do is you reorganize the values within the matrix. So these two values here we swap. So you write 18 here and minus 2 here. And these two values here, you change the sign of them or multiply by minus 1. So this value will become a plus 6 and this will become a minus 6. Now here we encounter a problem. 1 divided by 0 we cannot do. This doesn't exist. So if this is the case, then d to the power of minus 1 does not exist. So it's impossible to find the inverse of that 2 by 2 matrix D. For these two parts, there are a couple of things to remember. Firstly, the formula for determinant and inverse are both given in the exam. It will be on the last page of the exam paper. Be very careful when you go to multiply signs that you remember that a minus multiplied by a minus is a positive number, and a minus by a plus or a plus by a minus will give you a negative number. Also remember that you can only find the inverse of a square matrix. And for this course, all we have found is the inverse of a 2 by 2 matrix. But in this example here, we've also found that the inverse of a 2 by 2 matrix does not exist when the determinant of the matrix is equal to 0. Now let's move on to the fourth part of the question. Here what we're asked to do is multiply A by B, AB, and subtract C transpose. So when you see C with a T raised above it, that means it's the transpose of C. Let me do the multiplication, A multiplied by B first. So I write down the two matrices next to each other. Before you start the multiplication, I have to investigate if it is possible to do the multiplication. And to do the multiplication, what I do is I write down the order of each matrix. So the order of A is that it's a 3 by 2. It has 3 rows and 2 columns. The order of B is that it's a 2 by 2. Now, if two matrices A and B are to be multiplied, these two numbers here that I'm putting a box around have to be equal. In this case they are equal, so I can multiply. If at this stage you found that these two numbers are not equal, then you would have to finish with the problem and just conclude that it's not possible to multiply A by B. However, in this case it is. And not only that, but the two outside numbers here, right, will show me what the order of the solution matrix is. So the solution matrix for A multiplied by B is going to be a 3 by 2. So it's going to look like the matrix A in form. So let me form the solution matrix. As I said, it has 3 rows, right? So 1, 2, 3 rows, and it has 2 columns, 1, 2, 3 again for the 3 rows. So the solution matrix is going to look like this. Now let me fill out each of the individual entries. This entry here, let me underline it again. It's in the first row, first column. So what I do is I take the first row of A and I multiply each of the individual entries by the corresponding entries in the first column of B, and I add them together. So what I get is 4 multiplied by 1 plus 10 multiplied by 3. And if I write the answer out here, the first entry in this matrix is going to be 30 plus 4, which is 34. Now let me take a different colour and I'm going to fill out this entry here, which is in the first row, second column. To work out this entry, again take just the first row of the first matrix, but this time I multiply it by the corresponding entries of the second column of the second matrix and I add them together. So what I get is that it's 4 by 9 plus 10 by minus 4. And again, if I work this out, 4 multiplied by 9 is 36. 10 by minus 4 is minus 40. So 36 minus 40 is going to give me minus 4. Now I'm going to work out the element that's in this position here, which is in the second row, first column. So what I do is I take the second row of matrix A and I multiply it by the first column of matrix B. So what I get is that it's 1 multiplied by 1 plus 3, or minus 15 I suppose, minus 15 multiplied by 3. So when I do that, 3 multiplied by 15, minus 15 is minus 45, minus 45 plus 1 is going to give me minus 44. Working out the next entry, which is in the second row, second column, again I take the second row of the first matrix and I multiply it in this case by the second column of the second matrix. So what I get is that it's 1 multiplied by 9 plus minus 15 by minus 4. And that gives me minus 69. Now working out this entry here, which is in the third row, first column. Then I move on to the third row of the first matrix and I multiply it by the first column of the second matrix. So I get that it's minus 3 multiplied by 1 plus minus 2 multiplied by 3. And that gives me the value minus 9. Now I work out the last entry, and the last entry, is in the third row, second column. So to get that entry, I take the third row of the first matrix and the second column of the second matrix, and I multiply the corresponding entries, adding them together. So what I get is that it's minus 3 by 9 plus minus 2 by minus 4. So it's minus 27 plus, and that's a minus 2 there, so plus 8. And minus 27 plus 8 is minus 19. My next step is to take matrix C, and that's the C that was given at the beginning of the question, and I want to work out C transpose. So the T stands for a transpose of a matrix. And what transpose is that it writes the rows as columns or the columns as rows, whichever way you want to look at it. So C transpose for this matrix, what I do is I take the first row, which is 6 minus 1, 3, and I write it as the first column of the matrix. Then what I do is I take the next row, the second row, minus 12, 4, 4, and I rewrite that now as the second column of the matrix. So minus 12, 4, 4, and that gives me C transpose. So to complete the question, what I want to do is I want to take the matrix that I got for AB, and let me just correct a mistake I just see here. That should read a positive 69. And I want to subtract it from C transpose. So I write down the two matrices and I put a subtract sign between them. And to be able to do it, just like I said before, to do a subtraction, the matrices have to be exactly of the same order. And these two matrices they're 3 by 2 matrices. And to do the subtraction, I just subtract corresponding entries. So for the first entry, it's 34, and I'm subtracting 6 from it. 34 minus 6 is 28. The next entry, minus 4, and I'm subtracting minus 12. So minus 4 minus minus 12 turns out to be minus 4 plus 12, and that'll give me the value 8. The next one is minus 44, a minus is a plus 1. So minus 44 plus 1 is minus 43. The next one is 69 minus 4, that's just 65. The next one is minus 9 minus 3, which will give me minus 12. And the last entry is minus 19 minus 4, which will give me minus 23. So that's the answer. So a point to recap on is when you're multiplying two matrices, make sure that it's possible to do. And for it to be possible to do, as we did multiply A by B, the number of columns of A, which was 2, has to be equal to the number of rows of B, which again was 2, in order to be allowed to do the multiplication. And the resultant matrix is formed by these two outside numbers here, 3 and 2. The resultant, or the solution matrix, is a 3 by 2 matrix. Now let's move on and do part D. Part D, I'm asked to find the new coordinates of the point 6.2, minus 0.9 when rotated in a clockwise direction by 45 degrees about the origin. First thing to remember is that in the exam you're going to be given the matrix that rotates any point in a counterclockwise direction about the origin. And that's it written here. It's the cosine of theta minus the sine theta, cosine theta. Make sure that your calculator is in degree mode, because I'll give you the angles in degrees. And cosine and sine are a button on your calculator that you'll see, COS and SIN. In the exam, we're given this formula, and the formula is for a counterclockwise rotation. The Question we're asked here is actually for a clockwise rotation, and it's by 45 degrees. Now, a clockwise rotation of 45 degrees is equal to a counterclockwise rotation of 360 degrees, which is your complete revolution, minus the 45 degrees. So that is a counterclockwise rotation of 315 degrees. So this is going to form my theta in the formula over here. So the rotation matrix for this particular question is for a clockwise rotation of 45 degrees is going to become the cosine of 315 degrees minus the sine of 315 degrees, sine of 315 degrees cosine of 315 degrees. Now if you take out your calculator and work out the cosine of 315 degrees, you'll discover to 2 decimal places the answer is 0.71. If you work out the sine of 315 degrees, you'll discover that to 2 decimal places the answer is minus 0.71. So if I fill in the last 2 places, this is going to be 0.71 also. And this one here is going to be a minus and a minus, so it's going to be a plus 0.71. Now to get my new coordinates, what I do is I take the matrix of rotation, which I've just formed over here, 0.71, 0.71, minus 0.71, and 0.71. And I multiply it by the point that I want to rotate. So that point is 6.2 and minus 0.9. 0.9. So now here I am into a matrix multiplication again. This is a 2 by 2 and I'm multiplying it by a 2 by 1. These two figures are equal, so I can multiply them. And the resultant matrix that I will get is a 2 by 1. So let me write it out over here. Okay, so it has 2 rows and 1 column. Now if I write out the answer for the first entry, the first entry is in the first row, first column. So what I do is I take the first row of the first matrix and I multiply it by the equivalent entries in the first column of the second matrix. So it'll be 0.71 multiplied by 6.2, and I add them to 0.71 multiplied by, the last value is minus 0.9. To get the second entry, I take, and the second entry is in the second row, first column, I take the second row of the first matrix and I multiply it by the first column of the second matrix and add the corresponding values. So 0.71 minus, it is, minus 0.71, multiply that by 6.2 and add it to 0.71 multiplied by minus 0.9. Sorry, running out of space there. Now if you take out a calculator and do that calculation, and I round the two values to 2 decimal places also, the answer turns out to be 3.76 for the first value and minus 5.04. There's a decimal point there for the second value. And if I write them as my normal xy coordinates, what it will look like is the new coordinates will be 3.76, comma, minus 5.04. So that's the solution of the question. So the couple of things that I want to highlight for you to remember is, firstly, the formula that you'll be given in the exam is for a counterclockwise rotation. So if you're asked, as you are in this question, for a clockwise rotation, then you have to convert that into what it would be as a counterclockwise rotation by taking the angle from 360 degrees. Also, when you're working out the rotation matrix, make sure that your calculator is in degree mode, because I will give you the question, the angle of rotation in degrees. Now let's move on to the last part of this question. And the last part of the question for matrices is express the following system of equations in matrix form and solve this system using matrix methods. The first thing I have to do is to set up the problem as a matrix problem. And how I do that is as follows. I form a matrix, which is going to be a 2 by 2 matrix, which includes the values for the x-coordinate, which is a 5 and a 1, and the values for the y-coordinates, which is -2 and 3. So if I take that matrix and I multiply it by xy, then what that's going to be equal to is 9 minus 5. Now if I want to solve for xy, that's going to be equal to this matrix here, 5, 1, minus 2, 3, the inverse of that matrix, multiplied by the 9 minus 5. Now we have worked out the inverse of a 2 by 2 matrix earlier on, and we have a formula for it. If I want to just write it down, it's 1 over the determinant, and the determinant is given by 5 multiplied by 3, subtract minus 2 multiplied by 1. And then what we do is we multiply that by a reorganization of this matrix. We swap the 5 and the 3, and we change the sign on the other two. So it's a 2 and a minus 1. And that's going to be multiplied by 9 minus 5. And if I work that out, that's going to be 1 divided by 5 threes are 15, minus, and that should be a minus there, sorry, minus 2, so it's plus 2, so that's going to be 17. And I'm going to have to multiply 3 minus 1, 2, 5 by 9 minus 5. So this is a multiplication, and let me just move it down to get a little bit more space. What I'm going to get, what I'm going to get then is that it's equal to, equal to 1 over 17, right? And this is your 2 by 2 multiplied by your 2 by 1, and we've done this earlier. These two are similar, they're equal, so you can multiply, and the answer is going to be a 2 by 1. So a 2 by 1. So you're going to, for the first entry, it's in the first row, first column, so you multiply the first row by the first column, and you add the values together. So 9 by 3 is 27, plus 2 by minus 5 is minus 10. So 27 minus 10 is going to give me 17. The next multiplication, this value here is in the second row, first column. So you multiply the second row by the first column. So you get minus 1 by 9, which is minus 9, and 5 by 5 is minus 25. So 9 minus 25 is equal to minus 34. So if I multiply this matrix by 1 over 17, what I get is that it's 17 divided by 17 and minus 34 divided by 17. And 17 divides evenly into both. What I get is 1 minus 2. So the answer turns out to be that x is equal to 1 and y is equal to minus 2. I have included along with this video tutorial 2 files which I'd like you to print off. The first is a Word document that contains the question that I've just gone through, and there's no solution written in this document, so it will allow you to try this question yourself. The second document is a PDF file, and included in the PDF file is the solution, and I've highlighted various points that are important to remember for each part of the question. Thank you.